All right, so this is for our 2.3 homework on proving triangle congruence. All right, so we're looking at this, and our goal is to prove that the two triangles are congruent. Triangle MNQ, so this top triangle, and triangle PNQ. All right, so two triangles. Again, like we said in class, if it's easier to split them up to see, I mean, this one's kind of easier to see that they're two separate triangles. Sometimes, they line up. It looks like one big mega triangle. We can always split up, right? That's fine. All right, so what do? We've got this two-column proof statement versus our reasons, and we've got some options to choose from for both of them. So for statement, I honestly, even starting this, like I know we have there's a lot of negative thinking and thoughts towards proofs. I'd recommend, honestly, in the beginning, don't even worry about the proof. Like just ignore it for a moment. Let's focus on the figure and then we can come back and look at the proof. So we're looking at this figure and we're like, oh my gosh, this says 30, M and Q says 30, and also Q and P says 30. So we're gonna draw those arcs just to show that those two angles are congruent, right? Because they're the same. They're both equal. They're both 30. We're looking at this obtuse angle. We're like, oh my gosh, they said this one's 107. And what do you know? This guy down here is the same, 107. Those are two other angles that are congruent, is NQP and NQM. All right, so we know the angles are congruent. And again, our goal is to prove that they're congruent. So there's nothing else they're telling us, right? They're not specifically giving any more tick marks for sides or any more, arcs to show the angles are congruent. So from here, we have to think, do a little more critical thinking of what could be congruent. What else is there to look at? All right, so like we said in class, it was actually first day, but like we said in class, we can kind of split these up. Anytime we've got triangles that are smushed together, sometimes it's helpful to just kind of separate them out to see what's going on. So we've got, again, triangle NQM, and then we've got triangle NQP. All right, we've got our two triangles. Right? So the only thing that's like interesting, unique about this figure is the two triangles are smushed together. And if you already know the answer, awesome. If not, we're gonna go a little slow with what's happening here. So we're looking at this, we're like, this is interesting. They're both, right? It's like we've got repeats of QN and QN. So if this QN, let's imagine, right, just like we did in class, this distance is 10, and this second triangle, this distance is 10. We're asking ourselves, okay, like what would this distance be? What would this guy be? What would this side length be? We know like overall and Q10, this guy's 10, right? This would end up being the same. It's also going to be 10 for that distance. How is that helpful? It's helpful to remind us that NQ is the same thing. NQ equals NQ, right? They're the same thing. Remember we called this the reflexive property? Reflexive property because it's like a reflection, right? NQ, right? Reflection. How does that help us? Well, we know, it's not going to be 10, but we know, hey, this side length is congruent to itself. NQ is congruent to NQ. And I know it's kind of weird to just put tick mark on one spot, but, right, there are two separate triangles. We're saying this side length is congruent to this side length. And I'm using 3 dashes just to separate it out from the 10 as an example. So looking at this, we've got an angle, we've got a side, we've got an angle. The triangles will be congruent by angle, side, angle. Again, sometimes it's nice to just start with the figure and then dive into the proof because I know we get a little anxious when we're seeing proofs, but we got this. All good things. We can do it. All right, so let's look at our first statement. They're saying angle P. Angle MNQ. Let's read this correctly. MNQ. Okay. It's congruent to angle PNQ. PNQ. All right, cool. Yep. And that was given. Yep, because they told us it's 30. And now the next one, angle MQN. MQN is congruent to what angle, which is specifically 107. I missed that. They're equal to 30. So they're equal to each other because they're equal to 30. These ones are equal to each other because they're equal to 107. The order does matter. So we're talking about angle MQN. So from M to Q to N. So how I like to think about it is we're ending, like the middle number is Q, and then we're ending with like the 30, right? We're going that direction. So it makes sense. It's going to be kind of like the inverse for the second triangle. P, we're starting with the furthest distance, going towards 107, just like here, and then going towards 30. If we were doing the opposite way, NQP, that wouldn't, it might take it, but being more mathematically correct, the order matters. So the measure of that angle, I'll say it in terms of congruence. So when we say measure of angle, we use an equal sign. If I haven't mentioned this yet, if we're just doing an angle, we would say congruent. So MQN is congruent to angle PQN. And we're talking about the measure, so now equal, but same thing. PQN, let's change that. PQN, there it is. All right. Now we need a statement to say that they are the same segment. And we're thinking back to what we found, right? There's only that the third piece that we were missing that was congruent, right? And that was this line segment is congruent. So Khan Academy didn't say reflexive property. They're keeping it simple, which is also helpful. And they're saying they're the same. They're the same segment. It's the same thing. So NQ equals NQ, right? NQ, NQ. All right, last one, we say the triangles are therefore congruent because of, as we said, angle, side, angle. Angle, side, angle. All right, let's go ahead and check. Yay! All right, we can look at one more real quick, and then I'll have you guys try the rest on your own. So we'll do like more of a speed round for this next one because I know I spent a lot of time on this first one. But in case we need another example, we'll go through this one as well, real quick. All right, Holden tried to prove that these triangles are congruent. This was his all of his information. What is the first error that he made in his proof? Okay, so let's see. Starting with what was given, IH is congruent to GH. Yep, and that's the correct order, going from I to H and G to H, right? Going towards point H, the vertex H, perfect. All right, so step one is good. Then he's saying FH is congruent to FH. Okay, we agree, because line segments are congruent to themselves. Okay. Line segments are congruent. Yeah, that's true. Sorry, I was like, hold up, what? Yep. FH equals FH. Remember, specifically, we would call this the reflexive property. Reflexive property, being fancy. But yeah, that works. And now he's saying the triangles are congruent because of side-side congruence. We're like, let's think about our different options here, right? We've got side, side, side. We've got all the different options, right? Side, 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 angle, side, angle, angle, side, angle, side, angle. What am I missing? Side, side, side. Right, the ones that don't work, do not work. Work is angle, angle. Angle doesn't work, and then we can't have donkeys. No donkeys allowed. So what am I missing? I'm missing hypotenuse leg. I'm trying to make sure if I'm missing any other ones. I think that was it. Side to side. Yep. Angle, angle, two angles. Side, side, angle. All right, hang on, let me check. Okay, yeah, I was checking. I was like, the only other combination I could think of is side, side, angle, but that's just the inverse of this, so we're good. These are all them. So he's saying side, side, and we're like, bro, the only one with 2 letters is hypotenuse leg. Everything else has to have 3, so it looks like his reason would be incorrect, I would say. And then let's see the different options. Again, this is one way. You could have started by kind of, annotating the figure and then going straight to what were the options and checking if they worked. But this is my method that I think makes more sense, but you do. All right, so Holden used an invalid reason to justify the congruence of a pair of sides or angles. Nope, the angles and sides were fine. Only established some of the necessary conditions for a congruence criterion. I mean, that's true. He didn't there we need a third statement before we can say they're congruent. All necessary conditions, but then use an inappropriate congruence criterion. All necessary conditions. Well, we're missing one more condition, so I don't quite agree with that. He used criterion that does not guarantee congruence. I mean, that's true, but there's only one answer, so we got to think about this. So, oh, and they're asking the first error. First error. I'd say the first error is he's missing this, right? He's missing a statement here saying maybe there's an angle or some other information. In this case, there wasn't. Seems like the triangles are not congruent. Some of the necessary criteria. Hang on, let me read this. Okay. These are like worded very, very strange. Okay. Holden only established some of the necessary conditions. Yeah, because he needs another one. Use a criteria that does not guarantee. Okay, that would be our second issue, is right. Side, that doesn't mean it's congruent. But before that, because we wanted to know the first error, this is a little confusing, but the first error that he made is that we need something more. We need at least 3 to prove. I'm going to say B. Let's check. Oh no, not quite. Was it D? Okay, let me see how we answered this question. I am curious. Use criterion that did not guarantee congruence. I mean, that's true, but he would be missing. Okay, let's see. So proof, 2-column proof, blah, blah, blah. Diagram does support the claim that IH is congruent to GH. Yeah, okay. Step 2 is correct. Step 3, in this step, Holden claims that the triangles are congruent using side to side. He established the conditions for claiming that they were congruent, but side to side is not a valid reason. Yeah, I mean, we said that, but criteria that does not guarantee congruence. Okay, well, this one was a little tricky. I feel like this one still makes more sense. That he didn't provide all the necessary conditions, but I don't know. Now that I'm thinking about it, seeing the correct answer, maybe that's incorrect because there was nothing else in the figure. These are kind of tricky for these ones, right? Because it maybe if there was like, they told us like, hey, this angle's congruent or this other side's congruent, then we'd be like, hey, he didn't include all of the conditions that was given. But he did. He put everything that was given. There was nothing else. He just picked the wrong reason. In this case, the reason would be, like it said, that they are not congruent. They're not congruent. All right. Well, hopefully this helps. Maybe. I don't know if there's other multiple choice that are exactly like this, but we gave it our best shot. We learned from our mistakes. So today we made a mistake, and that's okay. We learned from it. If you have any questions while you're working, let me know. I can also make another recording looking over these multiple choice if you need it. All right, take care. Bye, guys.